Now let's see the topic called parabola with an introduction of what exactly is a parabola. So now that we have discussed about circle, the next concept which we're going to discuss is about parabola. But before we discuss about parabola, we need to take the most important concept from which the circle, the parabola, or the ellipse, or the hyperbola, or the different types of two-dimensional structures are obtained through the conic sections. So the topic here is conic sections. So here with the conic sections, let's see how the different types of two-dimensional circle or a parabola etc. are obtained. So initially I take a cone. So we all know that it's a three-dimensional cone which I have taken here. So let's see the conic sections of the different types of structures or the shapes which are obtained through various types of cutting of the cone. Suppose I take this cone and I cut it exactly out here perpendicular to the base of the cone. So if I slice the cone perpendicularly with the base of the cone, then I get a circle. Is how I understand a circle through the understanding of a conic section. So here when I just cut it, I just have this cut in the form like this. We get a frustum out here. So this makes me understand that when I cut it exactly perpendicular, the base here is a circle which I obtain. So circle is indirectly said to be obtained through the perpendicular cutting of a cone through the base. That is the conic section of the cone which is perpendicularly cut out here gives me a circle. Similarly, we have the other type of conic section through which I get a parabola. So let's see what kind of cutting of a cone, in what angle of cutting of a cone I get a parabola. The conic section of obtaining a parabola is how we get the method here. So let's see how we get a parabola from the conic section. Now again we have a cone through which, let's see how I get a hyperbola or a parabola through the conic section in a different cutting through an angle. So in initial case I have seen that when I cut the cone perpendicularly to the base, then I get a circle. Then what happens if I don't cut that perpendicularly? That is, if I slice it somewhere out here. So in this case of slicing, I get a hyperbola through which, a parabola through which it comes like this. So a parabola which is generally U-shaped is what I get when I slice it in some other angle out here. Is what is the parabola when this is cut across the angle, then I get the parabola. So parabola is the conic section of the cone which is cut other than at 90 degrees to the base of the cone. So this is the shape which I obtain in case of a cone. And next, when I take a double cone out here, then in this case, if I just cut it twice, say I just slice it on, then I get a hyperbola which is in the shape of this. With respect to the axis, I get a slice on the top and I get a slice on the bottom through which I get a hyperbola, which we're going to see in the later part of discussing the conic section of the hyperbola. So if I have a cone where I have been cutting the cone perpendicular to the base, I get a circle. What if I cut this other than perpendicular or other than 90 degrees? You suppose I cut this slantingly. then what would be the shape I obtain here? In this case, when this is sliced, I get this to be somewhat like this. So this is cut in the slice where I get the shape which is called an egg-shaped structure, which is an ellipse. So an ellipse is an oval shape and it is obtained when I cut the cone other than at 90 degrees in this manner. Now let's define a conic. Suppose I have the axis and the directrix, and I have a fixed point S and a point here which is P, and M is the perpendicular distance from P to the directrix. Then in this case, the locus of all the points such that the distance from S to P by the distance from P to M are in constant ratio. That is, if I have SP by PM is always E, a constant, then the locus of all those points is called the conic. Implies locus of PXY is a conic under the condition SP by PM is equal to E. And here we identify that S is the focus of the conic, and here S, the fixed point S, is called the focus, which we generally denoted by S, is called the focus, and the fixed straight line is called the directrix, and the ratio SP by PM equal to E is called eccentricity. So here E is referred as eccentricity, and it is given by the formula SP by PM. And S is the focus, and here this is the directrix. This is how we understand each part of the conic. And the straight line passing through focus and perpendicular to directrix is axis, because this is perpendicular to directrix and passing through focus S is how we get the properties of axis and directrix connected with the conic. Now let's see what is the role of eccentricity in deciding the shape of the conic. So eccentricity plays a vital role in deciding the shape of the locus. That is, the E, which is SP by PM, has initially E equal to 1, implies SP is equal to PM. If eccentricity is equal to 1, that implies the conic is a parabola. Is how we understand the conic to be a parabola. Next, if I have E lying between 0 and 1, implies the conic is an ellipse. Is how we understand for E lying between 0 and 1. And next, if E is greater than 1, implies the conic is a hyperbola. That's how we understand the three basic properties: parabola, ellipse, and hyperbola. So therefore here, if I would like to find the equation of parabola, I just have the condition that for a parabola, SP by PM, which is equal to E, is always 1. That implies SP is equal to PM. So I get the locus where SP is equal to PM. So let's take the locus P as XY and the focus S as alpha, beta. And this is the axis passing through the focus, and this is the directrix which is perpendicular to the focus. And let the equation of the directrix be taken as Lx plus My plus n equal to 0. The question here is, how do I find the locus of P? So for locus of P, SP is equal to PM. That implies the distance from S to P using the 2 points is given by root of x minus alpha whole square plus y2 minus y1, which is y minus beta whole square. And PM is the perpendicular distance from P to M, which is given by the formula Lx plus My plus n by root of a square plus b square. And this, on squaring on both sides, gives us x minus alpha whole square y minus beta whole square is equal to Lx plus My plus n whole square by L square plus m square, which on simplification gives the equation of the parabola. On cross multiplication gives this. So this can be further modified as L square plus m square x minus alpha whole square plus y minus beta whole square is equal to Lx plus My plus n. Whole square is how we get the equation of the parabola using the condition SP equals PM, and it is a second degree equation in x and y. Now we are going to see the different types of equations for a parabola. So now that we have understood the mathematical definition of a parabola using the locus P with SP equal to PM, now let's see one of the equation, which is y square equal to 4ax. So one of the representation for a parabola is y square equal to 4x. Now this parabola will be in the form of this. So for the parabola y square equal to 4ax, assuming that a is greater than 0, here I have my focus S, which is given by a0. In case of the parabola y square equal to 4x, my focus is a comma 0 and my vertex is origin, and I have my locus P, which is x comma y, which is given out here. Then in this case, this is called the directrix and this is called the axis. And equation of axis is nothing but y-axis, therefore this is x equal to 0. And the directrix is given by x plus a equal to 0, and a point on this is minus a 0, because this is exactly at equal distances from the y-axis either way. Oh, this is y and this is x on either way. So using this, I have my focus, my point on the parabola, my directrix line, my axis, my vertex, which is origin, is how we understand the parabola y squared equal to 4x with a greater than 0. Also clearly, I see that the parabola passes through origin because if I have y square equals to 4ax and if I substitute x equal to 0, then I get y square as 4a times 0 substituted in place of x. That implies y squared is 0, which gives y equal to 0. Therefore, x equal to 0 implies y equal to 0. Therefore, the parabola passes through 0, 0 is how we get the concept. Parabola passes through origin 0, 0. Next, if I see out here, the y-axis is a tangent to the parabola exactly at the vertex. Therefore, I can say that y-axis is the tangent to the parabola y squared equal to 4ax at the vertex 0, 0 is how I understand the tangent at the vertex for the given parabola y squared equal to 4ax with a greater than 0. Now let's take the other type of the parabola in the form y squared equal to minus 4ax with a greater than 0. So what happens if I change the positive sign to the negative sign with replaced by minus 4ax? So let's see each of the properties of the focus, directrix, axis, etc. for the parabola y squared equal to minus 4ax. So taking the axis and the directrix perpendicular to each other, I get my 4ax, which is replaced with minus 4ax, makes me understand that my x is replaced with minus x. So mathematically I understand that if I have y squared equal to 4ax, if I replace this x with minus x, then I get the parabola y squared equals 4a times minus x, x replaced with negative x. This on simplification gives minus 4ax. So this makes me understand that all of positive values of x when are replaced with negative, or all x signs are replaced with minus x signs, then I get a parabola which is similar to y squared equal to 4x. So all my positive values of x get transferred to the negative. Therefore, the whole of the parabola on the right shifts to the left because plus x signs are replaced with minus x signs on the left side. So this being x-axis and y-axis, I have the parabola in the form y squared equals minus 4ax is in the shape on the left. It is the mirror image of the previous parabola with respect to the mirror y-axis. So I have the focus here, and I have the point here, which is xy, and the focus, which is minus a0, because I come to the negative side. My focus a0 in the previous case gets reduced to minus a comma 0, and this would be perpendicularly equal to the directrix. Which is the directrix. Now the directrix on the left is shifted to the right. Therefore, the equation x plus a equal to 0 is replaced with minus x plus a equal to 0, that is x minus a equal to 0. And then I have the y-axis which is remain fixed with equation x equal to 0, and the directrix, the axis of this would be y equal to 0. is how we understand the complete structure of the parabola, with the vertex being 0, 0. All x's are replaced by minus x's in order to get the properties of the parabola y square equal to minus 4ax. So the focus, which was a0, reduces to minus a0 because a is the position of the x coordinate, and my directrix, which was x plus a equal to 0, is replaced with minus x plus a equal to 0, which gives me x minus a equal to 0. My axis and my directrix and my y-axis are the same, and the vertex is the same, but the remaining change accordingly for the parabola y square equal to minus 4ax. So as we see the equation x square equal to 5, we clearly understand that x and y are swapped. So in place of x I have y, and in place of y I have x. That means the x and y coordinates are interchanged. So in this case of the parabola shifts to y-axis. Say for example I have the x-axis and the y-axis. The parabola is in this form. So this is how we get the parabola, where the vertex is 0, 0, and my focus would be 0a. So a0 shifts to 0a because x and y are swapped. X and y get interchanged, and hence each of its coordinates get interchanged, where a0 of the original focus gets shifted to 0a, where this is shifted here and this is shifted here in this form. So I get the focus to be 0a, and then with the point P, with the locus x, y, I get the directrix with this perpendicular to this. So the axis out here is this, given by the equation x equal to 0, and the directrix is here, given by the equation y plus a equals 0, is what we get. So each of the focus, the vertex, the directrix, and the axis are given with their respective equations out here. Y plus a equal to 0 is the directrix for the parabola x squared equal to 4ay. Now lastly, we have the type of the parabola in the form x squared equal to minus 4ay. So in this case, I clearly see that my y is replaced with minus y. That is, all the y coordinates are replaced with negative of, which makes me understand that if I have x-axis and y-axis, all my y's are replaced down. Therefore, the parabola would be downwards in this form. So if I take the axis out here, I get a parabola in this form with the vertex v equals 0, 0, and I have the focus s, which is given by 0 minus a, because all the coordinates get replaced with minus 5, so a gets replaced down here. Now in this case, I have a point P, which is xy, from where I take the directrix line and drop So this is how I get this, where my vertex is this, my focus is this, and my axis is x equal to 0, and my directrix equation is given by x y minus a equals 0. This is how I get each of the properties in for the parabola, which is in the form x squared minus equals minus 4ay with a greater than 0. Now let's take the equation of the parabola in standard form as y squared equal to 4ax, which is called the standard form of representing the parabola. Now with this, I clearly see that when I have this parabola in the form of x and y, I clearly see each of the x values are positive and are not negative, because y squared equal to 4ax is defined only for x greater than or equal to 0. If I take a negative value, this reduces to the root of a negative number, which is complex or imaginary. Therefore, this being y squared equal to 4ax is defined only for x greater than or equal to 0. Therefore, the first property which I identify in case of parabola is that y squared equal to 4ax is always on the right hand side of y-axis, or in the positive direction of x-axis, or in positive direction of x-axis. It cannot cross the negative direction of x-axis, as you can clearly see out here. So let's see the next property which is identified for the parabola y squared equal to 4ax. So examining the second property, I clearly want to investigate on what happens if I extend the parabola. What happens in the endpoints of parabola as I go on and on till the infinite distance. So in case of this, I clearly identify that as I proceed towards the right, the parabola starts opening up and the points move farther away from x-axis. This is because if I take, say, x tends to infinity, implies y squared equal to 4ax, that implies y squared tends to 4a times of x, which is infinity. Therefore, this on simplification gives y squared tends to 4a times of infinity, which is infinity. That implies y tends to root of infinity, because when y squared tends to infinity, y tends to square root of infinity. That implies y tends to infinity. Therefore, x tends to infinity implies y tends to infinity. And this makes us understand that when this x-axis goes till infinite distance, the points move infinite distance from x-axis towards y-axis on either side. So therefore, this opens up at infinite distance on the right, and therefore it is not closed. The parabola on the right is always an open curve. Therefore, the parabola opens up in the positive direction of x-axis. That is, y squared equal to 4ax is an open curve. Just like a circle which is a closed curve, parabola is not a closed curve, as supported by this mathematical property. A parabola is an open curve and a circle is a closed curve. Translation or shifting of the parabola. So let's see what happens if I shift the parabola from origin to any other place in all the 4 quadrants of the xy coordinate system. So translation or shifting of the parabola. Say for example, I have x-axis and y-axis. Say my original parabola y square equal to 4ax is shifted with vertex v00 to some v dash hk. That is, the vertex which is origin is shifted to v dash as some hk. So this being shifted here gives me the new vertex which is hk. So using this, the parabola equally shifts out here, which is obtained like this. Now this has the axis and it has the directrix and it has the focus, which we're going to define through the original axis. So this parabola which is translated here is referred with y square equal to 4ax, which is translated along the point hk, gives us the new parabola which is y minus k whole square equals 4a times of x minus h. Is the parabola out here, and the focus s, which s dash, which is ak for the original, a0 for the original, gives us a plus h comma k for the new parabola. And next, the axis of this parabola is given by the original axis for this being y equal to 0, gives us y equal to k. So the equation of axis is y equals k if the vertex is hk. Next is equation of directrix. Which in the previous case was x plus a equal to 0. So here my x coordinate being a plus h gives me equal to 0, or this can be x equals h minus a. This is how we get the directrix. So usually we assume this point to be x minus h and y minus k, which is generally the coordinates of x and y, through which we get each of focus, axis, directrix, etc. So equation of directrix is this, focus, axis is this, focus is this, vertex is this. Is how we get each of the properties which we define out here. So translation of a parabola from the vertex from origin to hk gives me the focus, the directrix, the axis given by these formulae. So now that we have discussed about a parabola and its properties, the next is about chord. As we have the chord for the circle, which is through the secant, similarly the line joining 2 points of a parabola is called the chord of the parabola. So if I take a parabola say y square equal to 4ax, then in this case the chord of the parabola is nothing but I take the 2 points P and Q and I just join the 2 points. So these 2 points form the chord. So here PQ is the chord, is referred as the chord of the parabola. So chord is the line which joins 2 points of the parabola, any 2 points of the parabola. The next is the focal chord. So what do you mean by focal chord? So a chord which passes through focus is called the focal chord. So now that we have discussed about the focus, let's see how a focal chord is obtained. Y square equals 4x. Now we know that a focus is the distance from vertex to S. So the chords which pass through the focus, say for example I take a chord which is passing through the focus, then this chord is called the focal chord because this exclusively passes through focus. So here PQ is called the focal chord because this passes through S. Now any line which passes through the focus is called the focal chord. Now as we can see here, there are infinitely many chords which pass through the focus. So the property here is that there exist infinitely many focal chords for the parabola, simply because there are infinitely many chords which can pass through the focus, and hence the focal chords are infinitely many in number. Now next is the double ordinate of the point. So what is double ordinate? So now that we have discussed about the chord and the focal chord, a double ordinate is referred of the point P. The locus is referred to the point P. Therefore, if I take a parabola with axis, x-axis and y-axis, then if I take the locus Pxy, then the double ordinate of the point P is a chord which is perpendicular to the axis of the parabola. So a chord which is perpendicular to the axis of the parabola is called the double ordinate. So here we need to understand that this is the axis and chord PQ is perpendicular to axis of the parabola, that is y equal to 0. So any line passing through P and which is a chord and which is perpendicular to the axis of the parabola is called the double ordinate. Is how we understand the double ordinate. The reason for double ordinate is if I take this as y and this distance will also be y, and therefore when you add I get 2y. Therefore the length of PQ is y plus y, and that is 2y, and this is double ordinate y, that is 2 times of y. Is how we understand the double ordinate connected with the chord of the parabola. Latus rectum. So let's understand what exactly is a latus rectum for the parabola. Suppose I take a parabola with x-axis and y-axis in the form y square equal to 4ax. I have the vertex here and my focus is out here. So latus rectum is defined as the double ordinate which passes through focus. A very simple definition where a double ordinate, latus rectum is a double ordinate passing through focus S. Now as I see here, interestingly, there is only one line which is passing through focus and perpendicular to the axis, which is called the latus rectum. So here L dash is referred as the latus rectum, and it is very important to note that there exists only one latus rectum for the parabola, because there's only one line which passes through the focus and which is perpendicular to the axis of the parabola. There exists one and only one latus rectum for the parabola. That's how I understand the geometrical property of a latus rectum. Chord, there are infinitely many chords for the parabola, and focal chords, there are infinitely many focal chords. Double ordinates, there's one double ordinate for that one particular point P, and latus rectum, there's only one and only one latus rectum for the parabola. Is how we understand the chords connected with the parabola. The four types being chord, focal chord, double ordinate, and the latus rectum.